alone? Or is there another Earth-like planet somewhere in the universe?
We have a fantastic goal yet for the next generation, which is to find planets that remind us of home.
I believe we're right on the brink of having the technological capability to actually answer a question that humanity has been asking itself for the last 2,000 years.
Another Earth could be as close as our nearest star system.
We're right on the threshold of being able to find these planets.
There could be twisted Earths under bizarre suns. Can we find these other Earths as they float hidden in the billions of stars and trillions of planets of the universe? Is there another Earth in the universe? It's perhaps one of the oldest ideas since mankind was able to look up at the stars and wonder.
Back when people were sitting around their campfires and looking up at the stars and imagining them as other campfires with other tribes around them.
What exactly do we mean by another Earth? It should support Earth-like life.
When you boil it down, life needs three very basic things to exist. It needs a liquid medium of some sort to do its chemical reactions in. And we think water is the most likely liquid medium. It's very prevalent in the universe. We also need to look for the basic building blocks of life, the molecules that can help to put life together, the phosphorus in your DNA. And we need to have an energy source. It turns out that a terrestrial planet that has water on it pretty much has all of those things we need.
Not all planets capable of supporting Earth-like life would have to be carbon copies of our own Earth.
So you can think of it like a series of different types of houses. If you go into a city, for example, there will be grand mansions, and there will be smaller, more modest little two-bedroom homes, and there will be city studios and skyscrapers and so on and so forth. All of these house people, all of these can help house life. And so we think about that when we go out into the universe looking. We're going to be looking for houses of all different kinds and keeping our minds open as to what could support life.
Astronomers have found over 300 exoplanets, that is, planets outside our solar system. The vast majority are gas giants, which are easier to find than small terrestrial planets like our Earth.
To build instruments to analyze those Earth-like planets, we have to anticipate ahead of time what the chemicals might be in that Earth-like atmosphere. For that reason, we need theory, we need models.
Victoria Meadows is in the planet modeling business. She heads up the Virtual Planet Laboratory at Seattle's University of Washington. The group, spread across institutions around the country, builds worlds that may exist in the yet unexplored universe.
The Virtual Planetary Laboratory allows us to simulate what planets might look like from space and what their environments might be like in advance of actually discovering these things out there in the universe. So it allows us to explore what planets might be like.
In the Virtual Planet Lab, fantastic worlds can be built, like a science fiction novelist with a supercomputer as a writing partner.
So we can take something that's like the Earth, but we whip away the sun, and we replace it with a star of different size and temperature. So what we've done with the Virtual Planetary Laboratory is modeled planets that started out as Earth-like and put them around stars that were much hotter, with much stronger UV radiation, for example, than our own sun.
The models can produce bizarre alternate Earths, filled with plants that are bright red, orange, or even pitch black. Photosynthesis can vary greatly depending on the light of the star that's shining on it.
Planets around F-stars, for example, where the light from the star is much bluer, the plants there will tend to absorb more blue light, and so those plants could potentially be more likely to reflect red, orange, and yellow light, and so will appear red, orange, and yellow to us.
plants on a world around weaker stars could evolve their coloration to use every bit of energy falling on them.
If you go down to much cooler stars than our sun, to M stars, plants on planets around M stars might in fact be black because they want to absorb as much light as possible to do their photosynthesis and to feed.
And then there's the water world planet, a theoretical Earth circling a volatile M-type star that constantly hits the planet with outbursts of deadly radiation.
And how does life cope on the surface of that planet? Is it possible to have life even when you have a flaring M star? It turns out that you can actually live about 9 meters underwater on a planet around an M star and still escape the worst of the flares, but still have enough light to be able to do photosynthesis and to survive.
Everything looks good from here.
And as future exploration missions are being drawn up, many scientists are focusing on what it would take to detect the byproducts of life on a distant planet.
Life produces gases. Life stinks. You can smell it. And we're going to look for those gases with these high-resolution spectrometers.
So what we really need to do is take the light from another Earth-like planet and analyze it to find out what the chemical composition of that atmosphere is.
Finding the locations of planets is something that UC Berkeley astronomer Jeff Marcy is very good at. He and his astronomy colleague, Paul Butler, are credited with finding more exoplanets than anyone else.
A planet that's farther from its host star will be very cool. And so there's a domain in between that we sometimes call the Goldilocks zone or the habitable zone, where the temperature is just right. And by just right, I mean lukewarm so that water would be in liquid form. And of course, it's liquid water that's the prerequisite for life.
When we look at other planets and we ask, could there be life on other planets? My first question is, could that planet support liquid water? Yes, I'm interested. No, I'm not interested. It all comes down to show me the water.
Water is an amazing substance. We are frankly fortunate that the universe has something called water. It's the great cosmic cocktail mixer. Water is the critical stuff that allows the chemical reactions to take place that eventually lead to life.
But this special zone, where liquid water can exist, varies from place to place. If a star is a hot O type, the zone will be farther out from a sun. If it's a cool M type, the zone will be closer in. And it even changes with time. Stars are not stable. Even our own comfy habitable zone here on Earth will change in a few million years when our sun grows older and much hotter.
We might be closer than ever to finding life in outer space. Scientists say they discovered a planet with the most Earth-like environment they have ever seen, about 123 short trillion miles away. Oh, come on. And it's smack dab in the middle of a place that could support intelligent life. Michio Kaku, physics professor, City University here in New York, and author of the Physics of the Future book, a bestseller in the New York Times bestseller book. How you doing, sir? And good morning to you.
Very good.
So it's only 123 million, I mean, road trip today, right? 123 trillion miles
a hop,
away.
skip, and a jump away. But
You say this is big and exciting news to astronomers.
This is big. This is really big. Astronomers have spent a lifetime chasing after the Holy Grail. The Holy Grail, an Earth-like twin in outer space. When you look at the constellation Libra, you'll wonder whether or not anyone is looking back at you from outer space.
So what are they seeing on this planet that they are so
This
attracted
planet
to?
may have a liquid ocean. If it was too close to the mother star, the ocean would turn to steam. If it was too far, the oceans would freeze. It's liquid water, we think, on that planet, and that's where life got off the ground. DNA, proteins, a mixing bowl of life is found in liquid water.
But right now, we cannot say whether or not there is a liquid ocean.
That's right. The next step beyond this now is to verify the fact that there is water on the planet, and the temperatures are just right to have water in liquid form, the universal solvent, the mixing bowl of life itself.
Do you see this picture on our screen right now? That's us to the left, right? And that's at, what is it, Jalise? How do you say it?
Yeah, Jalise 581G.
All right, now you told me it's relatively close because it's only 20 light years away. We can't prove it even if there is liquid oceans there, right?
Well, we can by using spectroscopy, that is looking at light from that planet, putting it through a prism, analyzing that light in a laboratory, and then we can detect the presence of water molecules. So we hope to do that and determine the atmosphere of that planet. So remember that this is the Holy Grail. People have spent a lifetime looking at it, and this could be that moment.
So next then is that you would take your best telescopes and train it toward that area
Well,
of space to
telescopes
get more
still can't
information.
see this planet because it's too dim. We look for the wobbling of the mother star, indicating that there's a solar system of planets surrounding that star. 6 planets, by the way, surrounding that mother star.
So it could be more at only 123 trillion miles. That would be a lot of gas.
Yes, right. It would take 300,000 years for the Saturn rocket to reach that planet.
All right, let us know what you find on that. Congratulations on the book. It's been a huge hit for you, and we'll see what happens with this one. Thank you, Michio.
Okay.
All right, Mark.